Hello everyone, my name is Aryan, and for today our topic would be about how are new elements formed. Elements are formed through processes that occur in stars and nuclear reactions. Understanding these processes helps explain the diversity of elements in the universe. Today we will explore nuclear fusion and the R&S processes of nucleosynthesis. What are elements? They are the building blocks of all matter in the universe. The periodic table organizes elements based on their atomic structure and properties. They are the simplest form of matter that cannot be broken down into anything simpler by chemical means. The origin of elements. Elements are created in stars through nuclear reactions. The processes depend on the star's size, temperature, and stage of evolution. These processes produce different elements and isotopes during stellar life cycles. Nuclear fission overview. So, nuclear fission is a process where a heavy nucleus splits into two lighter nuclei. This process releases a large amount of energy and additional neutrons. Fission is the principle behind nuclear reactors and atomic bombs. So, it is the process where a heavy nucleus absorbs another particle like a neutron and it becomes way too heavy, and then it breaks down into two lighter nuclei, and that happens because there are way too many charges in that space. There are way too many protons in that space. That is why it splits into two. How nuclear fission works. A neutron collides with a heavy nucleus such as uranium 235 or plutonium 239. The nucleus becomes unstable and splits into smaller nuclei called fission fragments. Energy neutrons and gamma rays are released during the fission process. So whenever a very heavy nucleus such as those of uranium 235 or plutonium 239, or those atoms which have too many protons, absorb another particle such as a neutron, it becomes unstable and splits into two smaller nuclei, and it in rare cases it may split into more, and it splits into two because there are way too many protons in that close space. Nuclear fusion overview. So it is the process where light nuclei combine to form a heavier nucleus. Fusion releases enormous amounts of energy. Similar to processes in stars, fission is considered a potential clean energy source for the future. So in this what happens, that a lighter nuclei combine to form a heavier nucleus, and these processes happen in mostly stars where there is enough pressure to overcome the Coulomb's barrier. How nuclear fusion works. Two light nuclei such as isotopes of hydrogen, deuterium and tritium collide at high speeds. When they fuse, they form a heavier nucleus like helium, releasing energy. Fusion requires extremely high temperatures and pressures similar to the sun's core. When deuterium and tritium combined due to a nuclear fusion, it happened because it happens in the cores of stars where there is enough pressure and heat to overcome the barriers, and the sum of those will be greater than the uh, new element form, that is helium, because some of the mass is getting converted into energy and an neutron is also getting emitted. Fusion in stars. Fusion powers the sun and other stars by converting hydrogen into helium. The energy produced in fusion radiates outwards, providing light and warmth. Fusion in stars creates many heavier elements over their lifespan. Elements such as carbon and oxygen are also produced in stars. When the when they fuse heavier and heavier elements, the radioactivity of the elements get lower and lower, and iron is the radioactive ash that is left, and after that they cannot fuse into other substances, and it gets collected at the core.
Good morning, sir.
Good morning.
The R process, rapid neutron capture. The R process occurs in environments with a high density of neutrons like a supernova. Nuclei rapidly capture neutrons before they can decay, creating heavy elements. This process is responsible for forming many of the universe's heaviest elements, such as those like gold and platinum. So this happens in intense events like supernova or kilonova, and it is said that in a kilonova the amount of about 10 earths are formed as gold and other heavy elements. So these are very rare events, but they are pretty effective, and this happens because the nuclei captures neutrons before they can decay during these intense events, and when that happens it becomes unstable and it converts the neutrons into protons, and that is how they are forming heavier and heavier elements. So this is the rapid neutron capture, where it captures neutrons at a very rapid pace, and then it converts those neutrons to protons. So that creates heavier elements. So moving on the next topic, the S process, slow neutron capture. So the S process occurs in aging stars during their late evolutionary stages. Neutron capture happens slowly, allowing beta decay to occur between captures. This process produces many stable isotopes of elements like strontium, barium, and lead. So in S process, what happens that it happens in all of the old late evolutionary stages of a star. The an nuclei gets an neutron at a very slow pace, and uh, and then they convert that neutron into the proton, which can produce many stable elements and many isotopes of elements like barium and lead. These two processes uh, were founded by a female scientist. Her name was Margaret, and the way she proved this was very interesting. To prove the S process, she pointed her telescopes at star and said if it has technetium, and metal that is formed by S process, that will prove that these processes are correct, and that is how these processes were founded. So the differences between R and S processes. So R processes occur rapidly explosive environments, while the S process is slow in stable stars. The R process creates the heaviest elements, whereas the S process creates lighter heavy elements. Both processes are essential for explaining the abundance of elements in the universe. So uh, thanks, thank you. And the principles that R and S processes work on. Beta decay transfers neutrons into protons, allowing elements to climb the periodic table. In this slow S process, a decay occurs between individual neutron captures. In the rapid R process, captures overwhelm and decay, creating unstable heavy nuclei that eventually decay back towards stability. So most of the times beta minus decay is happening, where the neutron is getting converted into the proton, and it is producing elements beta elements such as antineutrino and electrons, and beta plus decay. In this, what happens that the proton is getting converted into a neutron, and positron and neutrino are being produced. So they work on the principle of beta minus decay, where they convert neutrons into protons to make heavier and heavier elements. So thank you for listening, everyone. We are done with the presentation. Any further questions by anyone?
So, are there questions? Everybody has understood what Aryan is saying. If there is anything which you haven't understood, you can ask him. Who is raising the hand?
Sir, everything was clear.
Yes, Sir Arthraj.
Earth is asking what?
No.
Sir, I think so. He did it excellently. Any further questions, anyone? Sir, do you have any questions about that presentation?
Yeah. So the first slide which you showed. Okay, I think. Okay, let's. Do you know any process by which we do fusion also on Earth?
Sir, we create extreme environments to overcome these barriers.
Have you heard? Has anyone heard that? Is there can one do fusion also on Earth?
Yes, sir, I think so. Someone in there was something in China that had achieved fusion for 96 seconds. I've heard about it. It accelerates plasma.
Yeah, so that is called tokamak principles. Means you have a magnetic field, a toroidal magnetic field, in which what happens that you have the fusion elements are there, and
Yes, sir.
the temperature is made very high, almost that existing in the core of the sun,
Stars. Yes, sir.
and the fusion takes place. So that is one way. By the way, this one of the that is known as also you might read in the newspapers, ITER, ITER, which is done in France, and
Okay, sir.
India is also a part of it, of their development. And we have also tokamaks being built in Kolkata and in Ahmedabad, but they are smaller ones. So if you all get interested in future, so you can join this field because this is the upcoming field because we are looking for a fusion process.
Okay,
And do you
sir.
know where the fusion takes place on Earth
Fission.
or say in India?
Sir, if there is any heavier elements and if it strikes a neutron, it will just decay into two lighter elements.
No, but do you know any place where the fusion takes place in India?
In India, I don't have any idea about that, sir.
So all the reactors, they are built on the fusion principle.
Okay,
And we
sir.
have reactors. We have so many reactors in India. They produce about 8 gigawatt of energy, and all are based on the fission, which is the uranium and the plutonium, which is used as the fuel, and that breaks and the energy is produced. But are you aware that is there any place on in India where the new elements can be created?
Uh, Sir, I don't know any such laboratory.
Okay, okay. So the one place is in Kolkata, of which I was a part. It is a cyclotron.
Yes, sir, cyclotron. I
Yeah,
forgot
yeah.
about
So
that.
a cyclotron produces heavy, high energy particles, and you can convert one element to the other element. But they are in very small quantities. So,
Okay, sir.
and also there are many accelerators in India. So those are the places where you can join. And of course, you have the biggest accelerator, which is in Switzerland, sir.
Yes, sir.
So
Sorry.
there you can produce even quark.
Yes, sir.
And you have the fusion process there, and the sorry fusion process also taking place, and the fusion also takes place.
Okay, sir.
Basically, the fusion takes place there mostly. So, like say, gold nucleus collides with another gold nucleus. Many things happen. Yeah. So now we have a question from Earth. Yes, go ahead.
Sir, I have a question.
Yeah, go ahead.
Sir, if everything is made up of atom, we haven't touched a single thing yet.
We have.
We have not touched a single thing yet.
You haven't touched.
Sir, he's talking that atoms cannot touch. We only feel the electronic push of things, so it means that we haven't touched anything in our lives.
Okay. Yeah. Yeah. You're correct. Yeah. We are not touching anything. Means nothing
Sir,
comes
but
closer.
sir, but
Like say, if you want, if you wish to put your hand on the nucleus of hydrogen, you can't do it.
sir, that if सर अगर हम किसी को मुक्का मार दे तो हम भी ये भी कर सकते हैं कि मैंने उसको
वो
नहीं
तब
मारा.
वो तब भी नहीं होगा. अच्छा, we
सर
have yes, we have one question from here.
Saksham.
Her name is
Saksham.
Saksham. Yes, Saksham. What is the question?
Hello, Saksham.
Yes, sound is background sound is coming Earth.
Okay, sir. So I have a question.
You have also a
Yeah,
question.
Earth wants
Okay,
to ask a
okay.
question. Okay. So Saksham, I am coming to you. Earth, what is the question?
What are the different types of rock and how they form?
Different types of
Rocks and how they are formed.
locks. LOCKS.
No, sir. Rock. ROCK.
Acha, rock. Okay, let us first finish the discussion on one topic. Then we come and so Saksham, what is your question?
So, sir, my question is what is CP fin nuclear fission and how does it affect stars?